Alright, this video is going to be about interfaces. So interfaces are another of the fundamental concept of Java object-oriented programming, and they tie into both polymorphism and inheritance. So you have to make sure that you understand first inheritance, obviously, but also that you understand polymorphism in order to see that interfaces offer you a benefit. Okay, if you understand inheritance, but you are kind of a little light on understanding polymorphism, then this feature interfaces is not going to immediately appear useful to you. Okay, so make sure that you're prepared before to watch this video. So let's take an example. Okay, let's say that we have some code that manipulates a sort of paint tool, right? Where we are going to animate some geometrical shape on a canvas on the screen. So we are going to have different classes, okay, that represent actually two-dimensional shapes. For example, circles. The circle class represents circle, object, rectangle, triangle, and so on and so forth. Okay, so some operations are going to be common to all the shapes. So our software wants to manipulate those shapes, and some of the methods that we are going to have in all of those 2D shapes are going to be perimeter, that computes the distance around the shape, okay, and area, that, as the name implies, computes the area inside the shape. Okay, so each shape is going to feature those two methods, but obviously each shape is going to compute the area and the perimeter differently. Okay, so this is a classic example of where you would want to use inheritance. So you want to have a superclass, let's call it 2D shapes or shape, right? And you want to have three subclasses: circle, rectangle, and triangle. The area and perimeter methods are going to be defined in the superclass, but then they are going to be implemented and overridden in each of the subclasses. Okay, really the superclass cannot really know how to compute the area and perimeter of an arbitrary shape, but the subclass, which are specific shapes, knows how to do that. Okay, each of them knows how to do that. So what do we want to code? Those three subclasses, okay, each has the method, perimeter, and area. Okay, very well. Now what we want is, and this is where polymorphism is going to come into play, okay, we want the client code, so the code that is going to use those subclasses to be able to treat different kind of shapes the same way. That's really what we have been doing in the previous video with employee. That's the whole point of polymorphism, right? So example of that entail writing a method that prints any shapes, area of perimeter, regardless of what kind of shape the objects is, okay? Create an array to hold the mixture of the various shapes. So an array of shapes is going to be able to contain object of class circle, rectangle, triangle, just as before an array of class employee was able to hold object of class legal secretary, lawyers, and so on and so forth. We want to be able to write a method that could return a rectangle, a circle, or a triangle, or any other kind of shape. So instead of saying that the return data type is one of those specific classes, we would say that the return data type is the class shape. Okay, and then we want to be able to do something like a drawing panel class that can display all those shapes on the screen. All right. But here's a but, okay? Each of our class, circle, rectangle, and triangle, okay? I've been talking until now that there could be subclasses of a 2D shape class or a shape class, okay? And that would be great for this, right? Except that there are already a subclass of an object called, of a class, sorry, called drawable object. And this has nothing to do with our code. It's maybe like a class that comes, you know, with the Java library. It takes care of making sure that we can actually draw something on the screen, a canvas, for example. So bottom line is that I'm not going to go edit this class and insert inside this class, you know, the methods that I want to be shared among circle, rectangle, and triangle. This would be completely nuts, because if this is a Java library class, that's a good example, okay? A ton of other programmers worldwide are using it, and why would I insert in their objects, you know, perimeter and area, since it was never said that this class role was to compute the perimeter and the area? okay? It was not even said that this class role was to actually enable the display of circle, triangle, and rectangles. Maybe it was just for buttons in a user interface, settings, stuff like that. So really, I cannot just go and modify this class, even though I have actually one shot only at inheritance, okay? Any class can only inherit from one and only one superclass. So yes, I want to use polymorphism. Putting those method, perimeter, and area in the superclass of circle, rectangle, and triangle would be the solution. But since circle, rectangle, and triangle already inherit from another class, drawable object, then I cannot make them inherit from more than one superclass. And that's a problem in Java. Actually, that's a problem in a lot of modern object-oriented programming language. Other programming language allow multiple inheritance, so that's a topic we'll talk about in another context, okay? But for example, C++ allow a subclass to be a subclass of two different superclasses. That's not allowed in Java, it's not allowed in a bunch of other modern object-oriented programming language. But that means that we need some sort of alternative mechanism. If we cannot use inheritance, okay, of a superclass, what can we do? Here comes interfaces, okay? So what is an interface? An interface is a way to write down a list of methods that a class promises to implement, okay? So it acts like a contract in terms of behavior, in terms of method, and it says, well, if something is of the interface shape, that means it needs to provide a method perimeter and a method area, for example, okay, to relate this to our example. The idea of certification is completely, the idea of implementing those promises is the same as the idea of certification in the real world, okay? If you say I'm certified as a CPA accountant, okay, that means that people are going to expect you to be able to do some things. When you say I'm certified, quote unquote, as a shape, that means that you implement the shape interface. That means that people, meaning other programmers, are going to be expecting objects that implement that shape interface to respond to specific method call. Okay, so this is all this is about. But please notice that we are not talking about putting code actually in our interface. We just treat the interface as a contract that say somebody down the road is going to implement this and that method for you. So this is a big difference from inheritance, okay? Inheritance allows you to give a is-a relationship between classes, okay? And code sharing, which means that the subclass inherits all the code from the superclass. A lawyer, for example, inherits all the code from the employee, and then you can override some of it if you want, okay? Now, the interface also gives you that is-a relationship. So if you said, for example, employee was an interface, you could still define a lawyer class that implements that interface, and you could say that a lawyer is a kind of employee. So the semantic relation here, the logical relation between the class and the interface, and the class and the superclass, are very similar, but there is absolutely no code sharing. So back to our example, if we design shape to be an interface, shape is going to tell us, well, everybody who implement my interface has to provide perimeter and area. So a rectangle object can be treated as a shape everywhere. So if we have a variable that holds a reference to a shape, yes, we can put a reference that is to an object of class rectangle, okay, because the class rectangle implements the shape interface. But implementing the shape interface means that you have to provide the code for perimeter and area, okay? The shape interface didn't provide any code, so there's no code to inherit, okay? Sorry. So what's the deal with, doing something that is so similar but has this small difference, okay? Why is it so important that we cannot inherit the code from an interface? Well, the idea is that we can write actually classes that implement many interfaces. And there's not going to be, there are not going to be problems there, because implementing an interface just means, well, this interface says I should have, this and this and that method. This other interface talks about two more methods, and hey, there's one that is common between the two interfaces. It looks exactly the same. So at the end of the day, implementing the two interfaces just means that you're going to provide those methods. But there is no conflict there because there was no code, there was no over expectation in the interface. Then please have a method that, that matches this name, this return value, and this list of parameter. So that's why you can implement many interfaces. Now, you can only extend one superclass. So when you are stuck, like in our scenario for shapes, right, you cannot afford to inherit from more than one superclass, so you have to turn to interfaces. And this is why actually some object-oriented design professionals are suggesting that you should really use interfaces heavily, because most of the time when you use actually inheritance, you don't really need to inherit code. You could very well do your work without inheriting the code from the superclass, but what you need to do really is conform to a specific interface, a set of method. Okay, if that's the case, using the interface mechanism instead of inheritance means that that class that implements the interface can implement as many other interfaces as it needs, and it can still inherit from one superclass if it's needed later. Okay, once you have said that you inherit from a superclass, you lock down that class, so that's not so good. Okay. Quick remark here. Interfaces only feature abstract methods. So we're going to talk about abstract method and abstract classes, okay? But for now, let's just say that what we call an abstract method in this video is a method that has a header but no implementation, okay? So the name of the method, the data type of the return value, if any, and the list of parameter and the data type, okay? But no body to the method, no code actually to be executed. And interfaces also allow you to feature fields, but only final fields that cannot be modified. So let's take a look at the syntax used to define interfaces. So it really looks similar to the way you define a class, okay? Public, instead of public class and the name of the class, you have public interface and the name of the interface. And then inside you can have, like we said, final fields, but most of the time you have just headers for a bunch of methods. So notice that we have the name of the method here, data type of return value, if any, it's public, and then the type and name of each of the parameters, okay? And semicolon, no opening curly brace, closing curly brace, and code in between. No, just the header of the method. Here's an example. So public interface vehicle. Inside, we expect a public getSpeed method that returns an int, takes no parameter, and a public setDirection method that takes an int representing the direction and returns no value whatsoever. Okay? So going to our example about shapes, so we could have an interface shape, all right? Interface is, by the way, just like classes go into their own .java file, so the rule is the same. One public interface per .java file, and the name of the file needs to match the name of the public interface defined in it. And then we have our two methods, area and perimeter. None of them takes parameter, both of them return a double value. So the way we can represent this in a UML style diagram is we make a note here that this is an interface and not a class, right? So interface shape contains the methods area and perimeter, and circle, rectangle, and triangle, each of them implement, so we use a different notation here, a dash line, okay, a dashed line with an arrow. So those three classes implement the shape interface. So they do not inherit from shape. Shape is not a class, it's not a superclass, it's an interface. So one implements an interface and one inherits from a superclass, okay, two different things. So that just means that in this case, circle, rectangle, and triangle are bound to actually provide full implementation for those methods. And those implementations are going to be different, okay, in each of the classes here. But we have to have in each of those class implementation for those two methods because they said they would implement this interface. So how do we write a class that implements a given interface? The syntax is very similar to what we saw when we talked about inheritance, right? Public class, the name of the class, and instead of saying extend and the name of the superclass, you put implements and the name of your interface, Okay, so you are declaring here that this class implements that specific interface. Here's an example. Public class bicycle implements the vehicle interface that we defined 2 slides ago. Now let's talk about the edge cases. Okay, for example, public class banana implements our interface shape. So that means that we should provide area and perimeter, right, as method. But here's my class banana. It's completely empty, no code whatsoever. So I certainly do not implement area and perimeter. What happens when you do something like that? It's just not going to compile. When you say that you are going to implement the interface shape, this is a binding contract. Your class has to provide full implementation for those 2 methods that are defined in shape, okay? If not, well, there we go. You're going to get an error message. What about interfaces plus polymorphism? Well, one of our first motivation was we went to interfaces because we wanted to use polymorphism, but we could not because of the specificities of the scenario that we were in, okay? Namely that rectangle, triangle, and circle were already subclasses of a durable object class, superclass, and therefore we could not use, inheritance, but we still wanted to use polymorphism. So good news is that polymorphism will work with interfaces, no problem. That's what it's designed for. So here's an example. Public static void print info. So remember the print info method from a previous video. Well, this time we want to print information about object, okay, and the reference that we are passed as parameter to that method print info is a reference on an object of class shape. Well, shape is an interface, right? Okay, so is a reference on an object that has to be of a class that implements the interface shape. So it's getting long, okay, to say all of that. So a lot of people are going to say S is of type shape. S is an object of class shape, okay? So you see how we have, after repeating, these long sentences over and over and over, we end up adopting those shortcuts that are not necessarily technically correct, okay? But when you hear a programmer say here that print info takes a parameter of class shape, really what they mean to say is print info takes a parameter which is meant to be a reference to an object of a class that implements the interface shape. That would be the correct way to say it. And you can see here that this is really working out like polymorphism is expected to work out. So I can say the shape, and display information here about the object, and then tell the area. So displaying information about the object here because I put the reference to the object, I concatenate it to a string. The toString method that we already talked about is going to be invoked here. Okay, so if you have your own version of toString, perfect. If you don't, well, the default version of toString provided by Java for all objects is going to be called. It generally displays things that are not really, what you would expect in a user-friendly program. Okay, it's more like internal information. But if you redefine your toString, then you're fine. Then we display the area by calling area on S, perimeter on S. So everything that is available in the interface, okay, method-wise, we can call, okay, just like we could call every method from the employee class, when we had a parameter that was meant to be a reference to an object of class employee. And then if it's a circle, triangle, or a rectangle, then the correct versions of area and perimeter are going to be invoked. So here's an example here. We can create a new circle, put the reference in the variable circ, meant to hold the reference to an object of class circle. Same thing for triangle here. Then we call print info on the circle reference and the triangle reference. No problem. It's going to work for both. So we have polymorphism, and we have a way to work around that limitation that we can only subclass one superclass in each class.